By now you've been exposed to a little bit of information about fertility, mortality, and migration, as well as world population. We're going to spend the next few minutes looking at the demographic equation, which is simply an equation that shows the relationship between these things and an area's population. In a nutshell, we can summarize population change and the relationship between the major population processes with one equation. Population at time 2 equals the population at time 1 plus births minus deaths during the time interval plus in-migration minus out-migration during the interval for a specified geographic location. The equation can be used to determine any one of the components in the equation as long as you have all the others. It's the basis for population projection methods and a common method for estimating net migration. Here we have the data for the United States. We have all the components of population change between July 1st, 2010 and July 1st, 2011. This will make it really easy for you to practice using the equation. In this example, we'll estimate net migration, so that's the difference between in-migration and out-migration, using the data we have on population at time 1, time 2, and births minus deaths that occur during these two time periods. The calculated net migration here is not identical to the data that I provided in the prior slide. That's simply because the Census Bureau didn't just use this equation to calculate net migration, so their estimate is different, but it's very close. So here we have 311,587,816 as the population on July 1st, 2011. We have 309,326,225 as the population on July 1st, 2010. We have a little bit more than 4 million births minus 2,450,000 deaths. And we have a big question mark for net migration. A little bit of algebra to switch things around, and you solve for net migration, which is approximately 704,000 people coming into the United States from somewhere else. Natural increase is a subset of the demographic equation. In much of the world, there's more focus on natural increase than there is on net migration. The difference between the number of babies born and the number of deaths occur in a given time and place is your natural increase. So we can look at the natural increase between the world population in 2004 and the world population in 2013. The net natural increase during that time was approximately 740,796,000 people. So there were that many more births between 2004 and 2013 than there were deaths. In a closed system, natural increase is the only form of population change. The world as a whole is an example of a closed system. There are a few places in the world where migration is so carefully controlled that virtually all population changes from natural increase. These also happen to be places where it's hard to get good demographic data anyway, so it's not terribly useful. North Korea is a good example of this. When the term rate of natural increase is used by a demographer, this isn't referring to this kind of change in births and deaths over a specified range of time. It normally refers to the difference in crude birth rates and crude death rates at a given point in time. So the world's annual rate of natural increase in 2013 was about 1.2%. You can approximate an annual rate of natural increase using this if you wanted to. We could take this, divide by your starting population, and you get 0.12. But we're covering 10 years, so you need to divide that then by 10, and you get 0.012, which is 1.2%. It's an approximate way of getting at the natural increase in any point in time. But you can see how in demography it's all just basic math. Worldwide, natural increase is slowing down. Death rates continue to fall and birth rates are falling just a little bit faster, so the gap is starting to narrow a little bit, as you can see right here. The gap was much greater between the two here in the 1960s and the early 1970s. There's still a sizable amount of population growth, however. We hit the peak growth time some time ago, roughly 87, 88, And there's good reason to believe that at some point the world's population will stop growing again as we reach a point in which our low death rates are matched by equally low birth rates. But for right now, we're still looking at population growth in the realm of 700 million per year. Parts of the world are unlikely to reach that balance between births and deaths anytime soon. Other areas already have. The pale blue areas on this map represent countries that will experience virtually no population growth over the next 35 years or so, and possibly even negative growth between now and 2050. The darkest blue areas, here primarily through Africa and parts of the Middle East, and a little bit in Central America, these are areas that are experiencing high growth rates and whose populations will probably double by 2050. All of the other areas, the gray areas, have anywhere from a 26% to a 99% population growth rate between 2005 and 2050. That's a pretty big range. It's kind of hard to use that part of this map to really distinguish between the differences of much of Latin America, for instance, and parts of North America. But that gives you an overview of what kind of balance we're seeing between the relationship of dropping fertility and dropping mortality.